that last video was really long. I apologize for that. In this video, I want to say, well, how can I really easily, simply find the end behavior of a polynomial even without a graph? And one of the points that I was trying to summarize in the last video is that, well, it depends on it's all about the leading term. It depends on the degree, and it depends on whether it's positive or negative. All of that, you can figure out the end behavior from there. And so you could always graph it if you're not sure to figure it out too, which is just an easy way of solving it. But you know, it's helpful to be able to understand what's happening, because the end behavior is a very important trait in terms of visualizing what's happening in that curve without actually having to do any math. And that's one of the whole points of looking into this, is when I look at an equation or a formula for a polynomial, do I know what's going to be happening? But like looking at number 1, so to sort of summarize, if it has an even degree like it does here, both of the end behaviors are going to be going in the same direction. Polynomials always have to be going to infinity or minus infinity. So basically I have a limited set of options. Either both of these are going to be infinity or both of these are going to be minus infinity. And that's simply because it's a negative degree, or sorry, even degree on the leading term. Now, it has a negative leading coefficient. That tells us what's happening as we go to the right. As we go to the right, it's going to be going down, because this will be getting very big, and it will be negative. So as x goes to infinity, q will be going to minus infinity. Sorry, gotta get my tablet working once again, minus infinity. And as q goes to negative infinity, aka to the left, since it's even, it will be doing the same thing. And another way to sort of remember why it's going in the same direction is because x squared removes the negative from the input, right? So whether I'm plugging in a positive or negative, in either case, this is going to be positive and multiplied by a negative. So ultimately, it's going to be going down as it gets larger and larger and larger. And number 3 is actually exactly the same, because it's even and it has a leading coefficient. Even means same direction. Negative means both going down. And the same thing will apply to, say it was x to the 6th power or x to the 8th. No matter what that is, if its largest term is an even number, in the largest degree, that will affect the end behavior. Now, if it's odd, they're always going to be different, because when I plug in a positive, it's positive. When I plug in a negative, it's negative. So in the case of going to the right, x to the cube would be a positive value. And if I'm multiplying by a negative, it's going to be going down to the right. And as I go to negative infinity, it's always going to be opposite, because if I plug in a negative, the negative will, a negative to the 3rd power stays negative. And then multiplying by another negative will make it positive. And then looking at the last example, number 4, even means both in the same direction, and positive leading coefficient means both positive. So those are some shortcuts. Hopefully that's helpful. The end behavior is not something that you're going to be tested on a million times in this class, but it's very helpful in calculus when we're talking about limits, because it's a way of understanding, well, what's happening as I go to infinity or minus infinity, sometimes important thing to consider.